For this problem, we have a mass that's attached to a rod that's sticking out from the wall. It's attached to the wall. It goes at a 45-degree angle, and the mass is 20 kilograms. We know the rod is 1.25 meters. And for the second part of the problem, we're told we push on this mass with a force of 200 newtons. So the first part of the problem says, what's the contribution to the torque due to the weight, the mass of the weight? So we can define our torque as positive this way, just because I know it's going to rotate that way, so I'm going to just call that positive. Now, we know torque is equal to force times lever arm. So the first torque that I want to deal with is the torque from this weight. So that torque is going to be its force, which is going to be, force is mg, its weight. So it's 20 is the mass, times g of 9.8, times its lever arm. It's perpendicular lever arm. So this force is acting downward like this. So my lever arm, if this is where I'm rotating about, right there, the perpendicular distance is this far here. So we look at this, we have to figure out what this distance is for our lever arm. Now we have a 45-degree triangle here, and we know the hypotenuse is 1.25 meters. So if we use sine, we can figure out this distance here. So the distance L is going to be 1.25 sine 45. Now we plug that into our calculator, and we find that we get 173 Newton meters for the torque due to the weight. Now the second part of the problem wants us to find the total torque, assuming we push on this weight straight in the x direction with a force of 200 newtons. So let's just figure out the torque due to this force. So this is basically the same, except this time our force we know is 200, and our lever arm is going to be similar. This time the force goes this way, so our lever arm is this distance here. So we can see that this distance, knowing this is a 45-degree triangle again, we can use, if we look at this triangle here, find this distance, that's going to be cos 45. So cos 45 times 1.25 will give us the torque for this force, which turns out to be 177. So now all we have to do to get our total amount, or total torque, is add up both these torques. Torque from the weight plus torque from the force. So that's just 173 plus 177. Our total torque is 350.